We're looking at covalent bonding using dot and cross diagrams, which you've done at GCSE, but we kind of take one step further. We need to be able to describe covalent bonding and to represent it using dot and cross diagrams as well. But also at GCSE, as with a lot of things at GCSE, we used a rule or a model that worked up until then. We used something called the octet rule, and we talked about atoms wanting a full outer shell. And when we talk about electronegativity, which comes next, we'll talk about that more, but it's about certain nuclei or certain atoms having more attraction for the electrons than others, and sometimes they have so much attraction for electrons that you end up with an ionic bond, and sometimes the electron density is shared by two nuclei more equally, in which case we get a covalent bond. So we're going to still talk about the octet rule for now, but I want you to bear in mind that that is just you will have come across some dative covalent bonds by now. And what this is about is when one particular atom donates a pair of electrons. So if an atom has a lone pair, then instead of having to find another atom to share electrons with to make a bond, it donates both the electrons in its lone pair to effectively make the bond itself, and we call this a dative covalent bond. Ammonia is NH3, and nitrogen has used 3 of its outer bonding electrons to form bonds with covalent bonds with hydrogens, but it still has a lone pair. So when ammonia forms an ammonium ion, when it bonds with a hydrogen ion, it's able to give its lone pair to the hydrogen ion. If you think of what a hydrogen ion is, a hydrogen atom only has one electron in its outer shell. So if it's lost that electron to become a hydrogen ion, then basically it's just a nucleus. So the nitrogen atom can donate the lone pair to the hydrogen, and it can accept both those electrons to make an ammonium ion. So the non-bonding pair can be donated if another atom, ion or molecule is able to accept it. And whereas before we've been drawing covalent bonds just with a line, now we use an arrow to show that there is an atom that supplies both the electrons. So if you look at the textbook, they'll give you another definition to learn. We'll be looking at these in the lesson, so get this in your book. Oh, that's my son in the background pretending to be a dog. Definition of a dative covalent bond is one where a shared pair of electrons has been provided by one of the bonding atoms only. Write that in your book somewhere. Make sure you remember that. Make sure you learn it. Hello, doggy. So we have for the moment got this octet rule, and we'll go with it for now. And so we'll look at some examples that break it. So boron trifluoride is one of the ones that comes up all the time. Boron has 3 electrons in its outer shell. It's quite happy, if you want to talk about this in terms of happiness, it's quite happy to go around as BF3. So that's one example. Sometimes you end up with an atom that has more than 4 electron pairs in it. So if you look at page 57 in the textbook, if you look at SF6, then you've got an example there of sulfur with 12 electron pairs, 12 bonds, 6 bonds. So again, things that break the rule. Now these two are worth learning because they use them as examples. But if you want to pause now and just have a go at trying to draw what happens when BF3 reacts with NH3, And also see if you can draw, there's aluminium trichloride, AlCl3. Now this forms something called a dimer. Okay, so here's the answer. So you've got the boron trifluoride that's able to accept the electron pair from the ammonia, from the nitrogen in the ammonia to form one compound here. And there we've got the dimer of AlCl3, and if you draw out the dot and crosses, you will see that aluminium does end up with 4 electron pairs in its outer shell.